Hey everyone, welcome back to the channel. Before we dive into today's crucial climate topic, let me take a moment to send some positive energy your way. To all of you watching right now, wherever you are in the world, I sincerely hope you're feeling healthy, happy, and full of vitality. May your days be filled with good health and wonderful moments. Now, let's talk about something invisible in our atmosphere that's having a huge impact on our planet's climate. Methane is 25 times more potent than carbon dioxide as a greenhouse gas. That's right, while carbon dioxide gets most of the attention in climate discussions, methane is the silent heavyweight that packs a much more powerful warming punch molecule for molecule. Let's explore why this simple gas is so incredibly effective at trapping heat and what this means for our planet's future. When we talk about greenhouse gases, most people immediately think of carbon dioxide, and for good reason. There's a lot of it being released by human activities, and it stays in the atmosphere for centuries. But methane, which is just one carbon atom bonded to 4 hydrogen atoms, chemical formula CH4, is actually far more effective at trapping heat in our atmosphere. The 25 times more potent figure refers to methane's global warming potential over a 100-year period, meaning that over the course of a century, 1 ton of methane will trap as much heat as 25 tons of carbon dioxide. But here's something even more startling. If we look at a shorter time frame like 20 years, methane is actually about 80 times more powerful than carbon dioxide at warming the planet because of how it interacts with other chemicals in the atmosphere during its first few decades after being released. The reason methane is such a powerful greenhouse gas comes down to its molecular structure and how it interacts with infrared radiation, heat energy, coming from Earth's surface. All greenhouse gases work by absorbing specific wavelengths of this outgoing infrared radiation that would otherwise escape into space. Methane's particular molecular structure makes it extremely effective at absorbing some wavelengths that carbon dioxide doesn't, filling in gaps in the absorption spectrum of our atmosphere. Additionally, methane molecules are much better at capturing heat energy than carbon dioxide molecules. Each methane molecule is like a super efficient heat-trapping sponge compared to its carbon dioxide counterpart. Another factor is that methane affects atmospheric chemistry in ways that amplify its warming effect. It leads to increased ozone formation in the lower atmosphere, troposphere, and ozone itself is a potent greenhouse gas. It also prolongs the atmospheric lifetime of carbon dioxide through complex chemical interactions. Where does all this methane come from? About 40% comes from natural sources like wetlands, termites, and geological seeps. The remaining 60% comes from human activities, what scientists call anthropogenic sources. The biggest human sources are agriculture, particularly livestock digestion and manure management, fossil fuel production, leaks from oil and gas operations, landfills as organic waste decomposes without oxygen, and biomass burning. Cows and other ruminant animals are major methane producers because of how their digestive systems work. Microbes in their stomachs break down tough plant materials through fermentation, and methane is a byproduct that gets released mostly through burping, not flatulence as commonly believed. In the energy sector, methane leaks occur throughout the production and transportation of natural gas, which is primarily composed of methane. When we think about natural gas as a cleaner fossil fuel because it produces less carbon dioxide when burned, we have to account for these methane leaks that can offset much of the climate benefit. The atmospheric lifetime of methane is much shorter than carbon dioxide, about 12 years compared to centuries or even millennia for CO2. This means that if we stop emitting methane, its concentration in the atmosphere would decrease relatively quickly. This short lifespan is both good news and bad news. The bad news is that methane does its damage quickly, contributing significantly to near-term warming. The good news is that reducing methane emissions can have a rapid cooling effect on the climate system, buying us valuable time as we work to reduce carbon dioxide emissions. This makes methane reduction one of the most effective short-term strategies for slowing climate change. Scientists estimate that cutting anthropogenic methane emissions by 45% by 2030 could avoid about 0.3 degrees Celsius of global warming by 2045. a significant amount when we're trying to stay below 1.5 degrees of warming overall. The relationship between methane and carbon dioxide in our atmosphere is complex. Before the Industrial Revolution, atmospheric methane concentrations were about 700 parts per billion. Today, they're over 1,900 parts per billion, the highest in at least 800,000 years. While there's much less methane than carbon dioxide in the atmosphere, CO2 is about 420 parts per million. Methane's potency means it's responsible for about 1/3 of the human-caused global warming we're experiencing today. There's also concern about feedback loops. As the planet warms, natural methane sources like wetlands and thawing permafrost release more methane, which causes more warming, which leads to more methane release. Some scientists worry we could reach tipping points where these natural emissions accelerate dramatically, making climate change much harder to control. Measuring methane emissions accurately has been a challenge, but new technologies are helping. Satellites like the European Space Agency's Tropomy instrument can now detect methane plumes from specific facilities, helping identify superemitters, oil and gas operations, landfills, or farms that are releasing disproportionate amounts of methane. Aircraft surveys and ground-based sensors provide additional data. These measurements have revealed that methane emissions are often higher than official estimates, suggesting there may be more low-hanging fruit for reductions than we previously thought. Fixing leaky pipelines, capturing landfill gas, and modifying livestock feed to reduce enteric fermentation could all make significant dents in methane emissions relatively quickly and cost-effectively. The good news is that we already have technologies to address many methane sources. In the oil and gas sector, better detection and repair of leaks, vapor recovery systems, and replacing old equipment could cut emissions significantly. Some companies are starting to use drones and infrared cameras to find leaks quickly. For landfills, capturing methane and using it to generate electricity turns a climate problem into an energy solution. In agriculture, changes to livestock diets, adding seaweed or other supplements shows promise. Improved manure management and breeding programs for lower emission cattle could all help. Rice paddies, another major source, can be managed differently to reduce methane production. Even individual choices like reducing food waste, which ends up emitting methane in landfills, and eating less meat can contribute to lowering methane emissions. International efforts to address methane are gaining momentum. At the 2021 UN Climate Change Conference, COP26, over 100 countries signed onto the Global Methane Pledge to cut methane emissions 30% by 2030. The US and EU have proposed stricter methane regulations for oil and gas operations. Financial institutions are starting to consider methane emissions in their investment decisions. These efforts recognize that while we must continue reducing carbon dioxide emissions for long-term climate stability, tackling methane gives us a crucial opportunity to slow warming in the near term. It's like putting out the grease fire while also working to turn down the stove. Both actions are needed to prevent disaster. Understanding methane's role in climate change helps us see the full picture of our environmental challenges. While carbon dioxide remains the primary driver of long-term climate change, methane's outsized impact in the short term means we can't afford to ignore it. The fact that methane is 25 times more potent than CO2, averaged over 100 years, tells us that each methane molecule we prevent from entering the atmosphere has a much bigger immediate climate benefit than reducing a single CO2 molecule. This makes methane reduction one of the most powerful tools we have to slow global warming in the coming decades while we transition our energy systems to be carbon-free. It's a complex challenge, but also one full of opportunities for meaningful climate action that can show results within our lifetimes. Thanks for joining me to explore this crucial, but often overlooked aspect of climate science. Let's all stay informed and support efforts to reduce methane emissions. Our planet's climate depends on it. Stay curious, stay engaged, and I'll see you in the next adventure.